For today's geometry notes, we will start standard 8. You will need in class 33. We are beginning to talk about a new shape today called a parallelogram. So first and foremost, let's discuss what we need to know about a parallelogram, and then we'll see examples of how we can use those ideas to solve problems. Every parallelogram, first and foremost, is a quadrilateral. A quadrilateral is a clue about how many sides the shape has. Quad means that there are going to be 4 sides to our shape. And these are going to be polygons, so that means they'll have straight sides, they'll have corners, which means if there are 4 sides, that means we will also have 4 angles as well. But parallelograms are special versions of quadrilaterals because they also have 2 pairs of opposite sides, which are parallel. That's what gives it the name parallelogram. And that idea right there, a quadrilateral with 2 pairs of opposite sides parallel, is actually the definition of what it means to be a parallelogram. All right, now when that happens, there are all kinds of other things that occur along with our 2 pairs of opposite sides being parallel. First off, when we have parallel lines, that means we have a whole bunch of angle facts that we've learned in our Standard 6 and worked on in Standard 7 related to alternate interior angles, related to alternate exterior angles, related to consecutive interior angles, and then related to corresponding angles. Now, because we're dealing with a quadrilateral, a 4-sided shape, we won't have opportunities to see alternate exterior or corresponding angles, but we will absolutely have opportunities to see alternate interior angles. So I'm just going to write in a little reminder that alternate interior angles are congruent when we have parallel lines, and we'll also see consecutive interior angles, but those are going to be taken care of down here in some of these other properties that we list. Okay? What else is going to be true about parallelograms? Well, if we have a situation where both pairs of opposite sides are parallel, what also happens is that both pairs of opposite sides end up being congruent. Well, that ends up happening thanks to congruent triangles in CP/CTC. So if you're interested in understanding the proof for why that's true, make sure that you let your teacher know. Or you can go on YouTube, Proofs for Parallelogram Properties, and they'll be able to fill you in on the details for why. Another thing that happens is that 2 pairs of opposite angles end up being congruent. Again, thanks to congruent triangles in CP/CTC. And then we also have, this is where the consecutive interiors come back, we have 4 pairs of consecutive interior, but I'm just going to write angles because all of the angles in these pictures are interior. So consecutive angles are what we call them in parallelograms. And just like before with our parallel lines, consecutive interior angles were supplementary. And so these consecutive angles in our parallelograms are also supplementary. Now, if you think you're going to forget, make sure you give yourself a little note that supplementary means that they're going to add up to be 180 degrees. And then last but not least, another property of parallelograms is that the diagonals of the shape bisect each other. Now, this is a new use of the word bisect. So I'm going to draw a little picture here of a parallelogram. We need to draw it so that it looks like it has 2 pairs of opposite sides parallel. So they'd have the little flags to show that they're parallel. So that's parallelogram. The diagonals cross through the middle of that shape from opposite corner to opposite corner. So that would be one diagonal, and then this would be the other diagonal. So when we're talking about the diagonals bisecting themselves, we're talking about segments bisecting each other. Usually when we use the word bisect, it has to do with angles, but we're talking about segments this time. So what that really means is that that intersection point for the diagonals is a midpoint, not only for the first diagonal I drew in, but also for the second diagonal that I drew in. So we don't get 4 little segments that are congruent. We just get 2 pairs of congruent segments thanks to that diagonals bisecting each other property. All right, that's all the facts, believe it or not, that we need to know about parallelograms in order to solve the problems that are going to show up on your Standard 8 assessment. So the next thing we're going to do is try to apply that definition and those properties to find the requested values for parallelogram PQRS. So they're telling us in the instructions that all of these PQRS shapes are parallelograms. For each of these problems, we're also going to make sure that we're in the right mindset by circling whether the problem involves sides, angles, or diagonals, because that will help us to decide which of the properties will be used to build the equation. So, as we look at example number 1, they're telling me about the measure of angle QPS. So from Q to P to S, that whole entire angle, that whole entire corner, is going to be equal to 4x plus 6. So this is going to be a problem about angles. I don't know which property related to angles yet, but I do know that they're giving me angle information. Onward we go to the next piece of the given information, the measure of angle PQR. So tracing from P to Q to R focuses us in on this corner right here. So that 3x plus 6 is that angle measure. And so now my goal is to decide, am I looking at alternate interior angles? Am I looking at opposite angles? Or am I looking at consecutive angles? Because I have 3 facts up above. Parallel sides, which leads me to alternate interior angles. Opposite angles, which leads me to 1 fact. Or consecutive angles, which leads me to 1 fact. So when we're looking at these angles in example 1, they are right next to each other in the shape, which means they are going to be our consecutive angles. That tells me that I'm going to take those 2 algebra expressions, since they're consecutive, and I'm going to add them together to be equal to 180 degrees, because that's what it means to be supplementary. We've got a couple like terms that we can combine. 4x plus 3x is going to be 7x. Then we've got positive 6 and positive 6 again, which is going to end up being positive 12. Now we're in solving mode. So I'm going to take that positive 12 and subtract it from both sides to get the 7x's isolated on the left equal to 168 over there on the right. And then finish it out by dividing both sides by 7, and x will turn out to be 24. Now, it is important for these problems that you're always checking your instructions. There are often multiple things that we're trying to solve for. So x is almost always important. We've taken care of that. But then often we're going to need to use our x to help us answer some other kind of measurement question. In this case, they're asking me about the measure of angle QPS, which I actually have provided for me. We don't always get that lucky, but for this one, we know that the measure of angle QPS is going to be equal to 4x plus 6, but if I know my x is 24, I can replace that x with a 24, and then I can do that arithmetic to figure out what the measure of angle QPS is equal to. 4 times 24 plus 6 more is going to give me 102 degrees, since this is an angle, for the measure of angle QPS. All right, let's move on to number 2 and see what kind of a situation we're dealing with here. Given PS is equal to 5y minus 3, 2 letters, PS, that is a side. So I'm going to turn it to the side. 5y minus 3 is the length of this side right here. QR, again 2 letters, so that is a side of the shape. 2y plus 6. Our goal is to find 2 things, y and QR. Well, if I go back to my properties up at the top, Number 1 and number 2 are about sides. The first one says opposite sides are parallel, so that doesn't help me with measurements, but the second one says opposite sides are congruent. So this is what it means to be opposite sides, which means 5y minus 3 is equal to 2y plus 6 in order for those two sides to be congruent. This time I have like terms, but they're on separate sides of the equation. So I'm going to start by subtracting 2y from both sides so that all of those y's will be on the same side. 5y minus 2y is 3y. That minus 3 stays there. 2y minus 2y is 0, so that part's gone, and I just have a positive 6 left then. Adding 3 to both sides will allow me to get my 3y's isolated on the left equal to 9 on the right, and then divide both sides by 3, and y is going to turn out to be 3. So I've taken care of finding the value of y. Last for this problem, I need to find QR, but the good news is they tell me about QR again, so I don't have to work very hard to do that. QR is equal to 2y plus 6, so I'm going to take what I now know about y, the fact that it's equal to 3, and plug it in. So QR will be equal to 2 times 3 plus 6 more, or 12. All right, 2 examples down and 2 properties so far. We've talked about consecutive angles and seen how they add up to be 180, and then we've talked about congruent opposite sides and how those will be equal as well. On to the last example for this side of the page. Looks like we're dealing with 2 letters again, so let's see where those are located. QT. QT takes me into the middle of my shape, so that is a portion of this diagonal. Let's see if TS is similar. Sure is. TS, this portion of that diagonal is 3x plus 6. And then last but not least, PT. So that one's going the other way. I think I'm going to use a different color for that one right there. That one is equal to 5x minus 2. Put that up here because I can't really fit it in. Okay, so this is definitely going to be an example of a diagonal problem. Remember from up above, we said that those diagonals bisect each other. And so if we're thinking about what we drew in the picture up above, I marked this as a midpoint. So PT matches with TR, but then QT matches with ST. So even though we have 3 pieces of information, we're going to focus on these 2 because those are the ones that are congruent thanks to that bisecting fact about our diagonals. We might come back and use this one later. We'll just have to see what they ask us to find at the end of the problem. So 3x plus 6 and 5x plus 3 are going to be congruent. Since we've done a couple of review algebra problems, I'm going to speed through this one a little bit faster. Subtract 3x from both sides, which leaves us with a 6 equal to 2x plus 3. Subtract 3 from both sides, which leaves us with 3 equal to 2x. And then to finish that one out, we're going to need to divide by 2. So that means that x is equal to 3 halves. Or if you want to write it as a decimal, 1.5. Yes, decimals are possible. Double check your work if you get one, but don't automatically assume that means your answer is wrong. All right, we've taken care of x. Let's take a look at what else they want us to find. PR. Okay, for all the other problems, when they've asked me to find something, it's been sitting in my list of given information. If I go looking for PR, it's not there. So I need to think about how to find PR using some of these other clues. Definitely going to focus on how that PT is part of that diagonal, which means this other part would also be 5x minus 2. PR is the whole thing, so I would need to put those 2 together. Or another option would be to take the part, this PT, and multiply it by 2. because it takes 2 of those equal segments to cover that entire distance from P to R. I'm going to go ahead and simplify that times 2 first, 10x minus 4, which is the same thing you would have gotten if you did 5x minus 2 plus another 5x minus 2. But then we have what x is equal to. So we're also going to substitute that in to find an actual measurement for what PR is equal to. 10 times 3 halves, or 10 times 1.5 is 15, and then subtract the 4 off to get to PR equaling out to be 11. All right, go ahead and flip the page and meet me back here for a few more examples. All right, example 4 is up next. I am noticing I've got angle symbols in the mix, so I'm going to go ahead and circle that this problem is about angles. Angle QPS is up first, so that's this whole corner equal to 10x minus 9. And then angle QRS, this whole corner, is equal to 9x plus 3. So this is a situation where we have opposite angles now instead of consecutive. So if we refer back to our facts from the beginning, 2 pairs of opposite angles are congruent. So instead of adding them to be 180, like we do with the supplementary ones, the consecutive ones that are next to each other, when they're opposite like this, they are the exact same size, which means 10x minus 9 is equal to 9x plus 3. 10x minus 9 equals 9x plus 3. Subtracting 9x from both sides will just leave me with 1x. And then adding 9 to both sides will give me x equal to 12. So we've got x taken care of. And the next thing on my list is to find the measure of angle RSP. Another quick check of my given information does not show me RSP. So if I go look in the picture, RSP is over here. Well, that angle is not going to be the same as either one of these, but they are consecutive angles. So what I'm going to need to do to find the measure of RSP is first find one of these. So maybe off to the side, let's just take care of it up here. Let's plug in our x to figure out how big these original angles are. So you could do 9 times 12 plus 3 to take care of that, or you could use this one and do 10 times 12 minus 9 to take care of that. They should give you the same answer either way. So it looks like, if we take care of that calculation carefully, just to make sure, 111 degrees is going to be the measurement of those two angles. It's kind of hard to see that 11 there. So now thinking about the fact that these are consecutive or these are consecutive, to find the measure of RSP, we need to use the fact that we have supplementary angles in the mix. So if I already know that other angle is 111, I can subtract that from 180 degrees, and that will give me the number of leftover degrees for a measure of angle RSP. Looks like it's going to turn out to be 69 degrees. And now I've got my x and the measure of angle RSP taken care of. Opposite angles to help me write my equation, but then consecutive angles to help me track down that angle measure they were requesting. All right, 2 to go. Example 5, we're in angle mode again, it looks like. The measure of angle PTQ is up first. PTQ is right here in the middle of the picture. We haven't seen one of those yet, so I'm going to go ahead and mark that. Angle QPT is this part of that corner. So that's going to be, let's see if I can squeeze this in here, 8x minus 4 degrees. And then last but not least, the measure of angle TRS. TRS is down here in this bottom corner, and I'm going to mark that to match this one because I've already noticed something, 6x plus 12. These angles QPT and TRS are connected to each other by a transversal. Remember, this top side and this bottom side are parallel, so those are alternate interiors. So this middle angle is here to distract me right now. I don't need that one. I'm going to focus on this angle QPT and this angle TRS. Since those are alternate interiors and the sides connected to them are parallel, I can set them equal to each other, like we would have back in standard 6 when we had alternate interior angles. Subtract 6x from both sides and then add 4 to both sides. Divide by 2 to finish out solving for x. And then we'll do a quick double check of what else they want us to find. If we're looking for the measure of angle RTS, I don't think that matches any of these. So if we go to the picture and we check it out, angle RTS is this one right here where that T was sitting. And I feel like that's why they gave me this angle at the beginning. Those are vertical angles back from the past. Vertical angles are congruent. So to find the measure of the angle they're asking me for, I'm going to use that 3x plus 15 that matches it. The measure of angle RTS is congruent to 3x plus 15. So if I set those equal and I take my x, which is 8, and plug it in, I should be able to track down the measure of the angle they wanted me to find. 3 times 8 plus 15 more. The measure of angle RTS is going to be 39 degrees. All right, we're almost there. We have one more example. And as I take a look at example 6, I'm noticing that double-sided arrow. So that means this is going to have slightly more complicated algebra. We're looking back at some more complicated Algebra 1 skills so that we're ready for Algebra 2 when that rolls around for most of you next year. Let's take a look and see what kind of information we have. PT right here is x squared plus 12. But then PR, so I'm going to highlight PR, is 96. All right, that's a little awkward to label because they're kind of overlapping in this section, but PR is longer. Definitely involves diagonals. So if we remember that fact about how diagonals bisect each other, this section at the top is going to match this section at the bottom. So I can really use that x squared plus 12 for both of these little parts, which means it takes 2 of those, 2x squared plus 12s, to cover that entire diagonal from P to R, which is 96. The other option that you could have thought about is how this 96 gets divided in half to match with that smaller segment. So you could have said that one of those smaller segments is equal to half of the whole thing. I'll set this one up both ways just so that you can see that it won't affect our answer. So whether it makes sense to do 2 parts equal to the whole or a part equal to half the whole, you can get away with setting it up either way. All right, if you're doing this 2 parts equals the whole business, we're going to distribute probably to get 2x squared plus 24 equal to 96. Subtract that 24 from both sides to work on getting the x isolated on the left side of that equation. 96 minus 24 is 72. We are going to take a square root, it looks like, because I have a squared term but no regular x to the first terms. But I can't do that until I get that coefficient to go away. So I'm going to divide both sides by 2, which means x squared is equal to 36. And then I'm ready for my square root, which means x is either positive or negative 6 in algebra world. If I imagine plugging that back in to make sure both answers work, positive 6 squared would be 36, plus 12 more would mean that this segment right here is 48, If this one is also 48, that would add up to be 96, so it looks like positive 6 works. If I do negative 6 squared, it's no different. Negative 6 times negative 6 is still 36, and 36 plus 12 is still 48. So both answers are acceptable for x. If we went about the problem this way, we would, instead of distributing, just simplify over here. Half of 96 is 48. Subtract 12 from both sides and still end up with x squared equal to 36, and still square root to get both positive or negative 6 as our answers. All right, that does it for in class 33 and all of the properties and definitions related to parallelograms. I'll see you back in class.